Well, thank you folks very much for the terrific turnout of yet another Data Science Sydney, and I hope no one was turned away, because it looks like we're pretty much at capacity again. So, welcome once again. Who's here for the first time? Quite a few of you, great. Well, welcome, welcome. I hope you're all members of the Meetup group, and if you're not, sign up. We are just shy of 4,000 members now, but some more exciting things have been happening with Data Science Sydney. You would have noticed that last month we were running events pretty much every week, and I think I told you that it's time to get used to that, because more and more companies, particularly consulting firms and software vendors, want to be running sponsored events, which is great. So we had a terrific sponsored event from IBM last week. Unfortunately, I couldn't make it. Who was there? Who made the IBM event? Going forward, the next exciting installment of the Data Science Sydney expansion will be a new Data Science Sydney visualization stream. So while this group tends to focus, well, on all aspects of data science really, it tends to very much focus on things like machine learning and advanced statistical methods and so forth. I figured there should be a group to focus on something else that's very important and popular, which is visualization. And Stephanie where's Stephanie? Hiding. I know she's here. Is heading up that group. Also, that should start running in early October. I think it's October 9. We're about to announce the event. Another stream of Data Science Sydney that's about to come online, and it will be running at the Google premises in Piermont, is something that's, I think, very important, probably the most important issue in our field as a professional field, not just data science but analytics more generally. It's the problem of management, it's the problem of culture, it's the problem of strategy. So the Data Science Sydney management strategy and culture stream will address those issues shortly. Okay, so that was announcements. As always, I think it's important to thank our sponsors. We should thank IBM for the terrific event they put on recently. So I'd like to thank Data Robot yet again. They put on an event over a month ago, but that was just fantastic. So sponsors running sponsored events is great. And of course, the biggest sponsor of them all, the one that just keeps on giving, CBA, which provides these wonderful premises and those drinks and this food and keeps on doing it. Let's give CBA a hand. They're fantastic. Always too many people in the CBA team to mention, and I always fail to mention them all, but Perry's here. Where's Perry? There he is. So there's a man to be thanked for making this possible. Another one is Kevin Simonet. Is he here today? Hey Kevin, thank you very much. And of course, Andre Ivanich. We'll get there, we'll get there. Thanks Justin. So there's CBA, and of course, another stalwart supporter of this group who provides the video services that you see behind you, all the cameras and the lights, which then make their way to the Data Science Sydney YouTube channel. So if you miss a Data Science Sydney session, you can view it on YouTube, and that's all thanks to Greg Pearl and N-World. And what's N-World? It's a recruitment company. And who's Greg? He is a recruiter with enormous experience and passion for this industry, who's been, like I said, a stalwart supporter of this group and the R user group. And he's someone who has created and turned around the careers of quite a number of the people in this room, and may, I'm sure will, do that for quite a few more of you, and may do that for you. So if you're looking for a new job, or you're looking for an entry into the industry, or you're just curious about what's going on out there, Greg's the man to talk to. So that's Greg up the back, very tall fellow waving, you should know who he is. So thank you very much, Greg, and thank you very much, N-World. I should, of course, thank the sponsors who made venues possible when we first started. So when there was only 90 people attending, Atlassian was kind enough to provide premises which we outgrew. But Atlassian provided premises, they provided beer and pizzas. They were great, and we remain grateful to them and to Tim Garnsey and the team who made that possible there. We also very grateful to Vodafone, who was our first expanded venue, and again, thanks very much to Richard Hunt, who made that possible and continues to support Data Science Sydney and has presented to us more recently. So, I guess the last sponsor I should mention, as always, is Prescient, me. And what do? Well, among other things, the list is getting rather long, actually. But the one I should tell you about is our data science analytics training. And there are courses coming up in October. We have a new Python for data analysis course. We have our long-established and recently improved and revised Introduction to R course, Introduction to R and Data Visualization course, and our most popular course of all, which is basically a Machine Learning and Data Science 101, where you learn the key concepts of data science. You don't just learn the steps, you learn why they matter and how they can fail and what to do otherwise. And that's the Predictive Analytics, Machine Learning and Data Science for Big Data course, as well as the Advanced Machine Learning Masterclass. We've also got a number of exciting courses coming up, in particularly a text analytics course and a deep learning course. If you're interested in Prescient's training, well, you know me, I'll be around. Come and ask me a question. So, that takes care of the immediate announcements. Let's go on to introducing our first speaker. Our first talk this evening is on the topic of building text-based data products in the real world. And we have an absolutely formidable speaker in LUKAS TOMA, because when I read you his credentials, yeah, you'll see what I mean. LUKAS currently works as lead data scientist at Presley, a software as a service company building software for people working in external communications and public relations. That alone is pretty interesting, right? But he is also co-founder of data consulting company Noid and co-founder of data science bootcamp called Basecamp AI, which I'm sure quite a few of you have heard of. He was also previously an early employee at the Austrian travel startup Ullmann, and here is the really scary one, the 700 million euro, which means probably over $1 billion, Australian German fintech startup Creditech. Please welcome LUKAS.
Hey, can everyone hear me? Cool. Thanks guys for coming. What I would like to talk to you about today is, as Eugene mentioned, text data products in the real world. I will tell you why the real world there in a minute, but I hope you enjoyed. So about me, I mean, Eugene already mentioned a couple of that, so I would like to move on to what does Presley do. And I have a short video. I hope it works now, because it's better than me talking.
Most popular bloggers receive a news story
wait.
like this. There are no images.
Okay.
We lost their attention. Tough love. But if you want your story to catch fire, check out Presley. Communication teams use it to share rich media stories with influencers. Suppose you want to share a story about a new milestone your company achieved because, for instance, you're in the milestone business. You log on to Presley.com, write your story in collaboration with your team, drag and drop media, and create a story that stands out. In the contact section, you select influencers you've added, see what they've been up to lately, and send out your stories. It's like that Excel file with all your contacts, but smart and pretty and fast. Journalists, bloggers, or employees get a rich media email, go to your online newsroom, and can share your story in their newspapers, blogs, or on social channels you've never even heard of, like Swangify. That's not a real one. We made that up. Your dashboard tracks all the interactions and reveals opportunities for future projects. If you want to get your story told, contact us for a demo at Presley.com.
All right. Cool. So this is about Presley. I would like to also know something about you. So who of you guys are starting with ML or AI or data science or whatever you want to call it? Can you please put your hand up? All right, I had a few. Who are the people who are non-tech but working with data scientists? No? Couple? And who are data scientists or like people working with data on everyday basis? All the rest. Did I miss anyone? No? All right. So why this talk? What's the reason for making this talk? I think many of you are familiar with the Netflix prize. It's kind of overused example in data science lectures and courses and whatnot. But what people use it for is an example of a success story. What I would like to use it for is an example of a tremendous failure of data science. Can someone tell me why that is? Or does it? Sorry?
Because it was never implemented.
Yeah, exactly. So it is a solution that cost $1 million. A lot of people worked on it for a lot of years, and it actually never seen production. So it was never used in practice. And I think this is a fundamental problem in a lot of techniques that are being developed. And there is 4 factors that come into play when you try to decide on a method that you want to use on your data science project. One of them is data, which is obviously what does my data look like? Do I have the data that I would need? And if I don't have it, can I get it? Either legally or do I have enough money to get the data? Another problem is accuracy. So how accurate my algorithm needs to be so it makes sense to use it in my use case, right? The third one is resources. And resources here can mean either development resources or just plain money. And the last one is runtime. So there's use cases where you can do with your algorithm running for a couple of seconds or minutes to do what it needs to do. But there's use cases where it needs to be millisecond or close to real time. And these 4 are interconnected, and unfortunately, a lot of them are trade-offs of each other, right? So the examples that I would like to talk to you today about are 3. One is related stories. I think that's kind of self-explanatory. Second one is matching influencers. This describes a problem that we have in Presley, that you want to match a particular piece of content to people in your database. And the third one is topic classification, which is if you have a piece of text, assign it to a particular category, right? Which in our case is media topics, but it can be whatever. So the first one on related stories. This is basically the problem, right? This is an actual story from Telenet, which is a television in Belgium, where they announced the season 7 of Game of Thrones. And for increasing time spent on the newsroom, conversion, whatever, we would like to add the related stories. The question here is how to make those. So there's a couple of requirements that we have on this algorithm or on this potential algorithm. Number one is there is long text, right? If any of you worked with textual data before, you know that the length of text plays a significant role. You cannot do as much with short text as you can with long. The second one is need for high precision. So the newsrooms of our clients are their public presentation space. So you cannot have irrelevant recommendations there because it reflects really bad on the brand of our clients. The third one is there's relatively few comparisons, right? Our biggest clients, probably Fly Emirates, have maybe in order of hundreds different stories in their newsroom. And this, as far as computers go, is not very many comparisons to make. And the last one is you don't need to do it real time. So it's okay if the related stories appear there 10, 15 seconds or a minute after the story is published, because the worst thing that can happen is that 5 people are going to see it before the related stories come up, right? And then we just don't display any. So the first problem you always have to solve when you do any data model based on text is make it numbers, because computers are really bad in dealing with strings, and the most trivial method to do so is called Vago Words, which basically, for those of you who don't know, is when you treat each word just as an occurrence. So you don't care whether different words are similar to each other. You don't care where the words are in text, what's the ordering. You just care that they're there, right? And one of the methods in this framework is called TFIF, which is kind of the first method that you would encounter. By the way, I would like to mention that there's links and resources for all of the methods at the end of the slide. I hope the guys can distribute the slide somehow afterwards, so you can follow up on anything by yourself and go deeper. Okay, so what TFIF does, it's two things. So the intuition is you count the occurrences of the words in a text, and if a word occurs more times in a document, it's more important, right? But then there is a problem that word like and or of or if would occur a lot of times in a lot of documents. So you penalize that, right? So you penalize the words that just occur in a lot of documents, and that's how you convert your text to number. What you do with that vector is something called cosine similarity. That basically means that you plot the vector into a space and calculate that little angle that's in between the two vectors. I also have an example for that. So imagine these two sentences. First one is data rules, and the second one is just rules. Our vocabulary is just two words, so it's easy to imagine it in two-dimensional space, right? So one would be just like an arrow on x-axis, and the second one would be point in 1, 1. And then you can calculate the angle in between these two lines, which is roughly 0.7. Don't kill me if the math is wrong. I calculated this morning. But here we come to the problems. So let's imagine that we have these two sentences, data rules and football rules. In this, data rules means like that data is awesome. Can someone tell me what the problem is here?
Rules governing football.
Sorry?
How to play football and what the rules are.
Yeah.
Two-dimensional sports.
Yeah. So there was too much input. But I think what the issue is here is that rules has a different meaning in these two sentences, right? But Vago Words would come up with pretty high similarity because it contains a common word, even though the sentences are completely different. In the opposite case, if you had two sentences where one would be data rocks and rules would be, again, in like a rock and roll sense of word, these sentences are actually similar, but they would have cosine similarity of 0 if you use TF-IDF because they just don't contain any words in common, right? So we worked out so far that Vago Words didn't work. So moving on to the next method, it's embeddings. Embeddings is this wonderful idea that you just take the text and come up with a different space where you can put your text, where you can embed it, where the relationships that you're interested in are going to be maintained. This is much harder to do than you could imagine, and it also doesn't make a lot of sense intuitively. But Tomasz Mikolov in Facebook came up with this really cool model to learn these embeddings really fast called Tuvok. I'm sure a lot of you have heard about it before. And it has two variations of the algorithm on the inside, but the intuition here is that what it does, it learns a neural network, so it learns the embedding space by looking at the words that are occurring around the word that you're interested in at every point. And what you will get when you learn a neural network like that, you will get interesting relationships. Like, for example, in that space, countries and their capital cities are going to be closer together, right? Because they would often occur in a similar context. Different tenses of a verb would also be close. And then you can do something that's called an embedding algebra, where there's this really famous example where you can do king minus queen plus a man equals, no, wait, I messed it up. King minus a man plus a woman equals queen. Right? So you can actually, if you add and subtract the numerical vectors for each of those words, it will actually come up with the queen. And that's pretty cool. So far, we talked about doing this for every word in a text. And that's a lot of work, right? And you would say, why can't we just do that for an entire document, where people thought about it and they say, yeah, we can do that for the entire document, so they did it. And it's called Tuvok. And Tuvok basically tries to learn a similar neural network. It just puts one extra node on the side that just stays there for all of the words in the same document and changes accordingly, so changes the weights all the time. And in the end, you will end up with representation of the entire document in that node. Again, the paper is in the resources at the end, so feel free to read it. It's pretty interesting. But why not? So does anyone have an idea why comparing one numerical vector for the entire document might be an issue? No. So the issue there is, what happens if you have more than one topic in a document? Well, nothing happens, right? You can get one numerical vector. So if the topics are kind of similar, then you're theoretically in luck. If the topics are opposite to each other, then you're in trouble, because then the vector will be something in the middle, and then it's going to be either similar to everything or to nothing. And we had a lot of these cases, because our clients publish stories like quarterly financial reports, or how did we do last year? And there might be good things, there might be bad things. There are financials, there are non-profit initiatives, and so on. So there is a lot of stuff that's not topically consistent. So this didn't work either. So we end up with something called word movers distance. This is a super neat algorithm based on Earth movers distance, which is a pretty good solution for a traveling salesman problem. And what this algorithm does, it's coming back to the word embeddings. So you would do the embedding per every word in a text, but you would try to optimize how much each of the words needs to move to become the closest to the closest word from the other sentence in the same embedding, right? So you're basically trying to measure how much the words need to travel to become the other document, and that's how you measure the similarity. It works really well. It's a lot slower than Tuvok, but as I said in the beginning, the time wasn't that much of a constraint, so we ended up using this one. I have again a couple of examples of the final product. So this is actually the one about Game of Thrones. Sorry, I don't know how to put it full screen, but you can see that all the related stories were about Game of Thrones, right? The television also publishes stories that are not about Game of Thrones, so that's pretty cool. Then there is an example from Fly Emirates, where you can see that they announced partnership with some other airline, and all of the related stories are about partnerships. But personally, my favorite one is this one about AB InBev. I don't know if you know the company, but it's one of the biggest manufacturers of beer in the world. But what's interesting about the story, it's not about beer. It's about that they made a commitment to be 100% running on renewable energy by 2025. And when you scroll down, all the related stories are about non-profit activities as well. And they're not the same non-profit activities, but the algorithm can pick up on the fact that there are stories about the extra things that they are doing, not the day-to-day business. So that's pretty nice. All right. The second problem that I want to talk about is matching influencers. Why is this problem interesting? Is couple of things. Number one is we're trying to match long text. So if our client writes a story, you want to match it to the people that they have in their database. And on these people, we have different data points. Sometimes we have a Twitter and tweets that they are posting. Sometimes we have articles that they published previously. Sometimes we have stories of the same client that they reacted to previously. And sometimes we have none of it, right? So the main issue here is that you have different kinds of data and texts of different lengths. The second one is this needs to be close to real time. Because if you imagine the user experience, you are making your story and then you click a button and you go, okay, who do you want to send your story to? And you don't want to like have a, you know, like a circle of death rolling there for 5 minutes and wait for your recommendations. It needs to be there instantly. And the last one is there's a lot of comparisons. So some of our clients have in order of tens of thousands of contacts in their database, and you need to compare all of them in those milliseconds of time. So let's say that we found out that word movers distance worked, right? What are the problems here? Why can't we just use it again? I mean, we know it works. So what's the issue? Sorry?
Too slow?
Too slow? Yeah. So the first problem is that it's too slow. Actually, that's the second problem that I wanted to talk about. Another problem? Another problem? No? Okay, so the first problem there is that the texts are of different lengths, right? So this wouldn't work because if you have an article that's half a page and you compare it to a tweet that has 5 words in it, it's very likely that you are going to find 5 words that are very, very close somewhere in the text. So everything is going to be very similar to the tweet. So what is the solution for the first problem that we found? It's text summarization, right? Make the long text shorter. There's a lot of algorithms that deal with text summarization. Most of them are not awesome. But this one that we explored works really well, and it's something that's called attention-based models. Why is it different? Again, I don't have time to get into it, how it works. But why is it really cool is because it doesn't only pay attention to the words in the text that it's summarizing when it's generating the summary, but also to the words that it previously generated, which again seems like an obvious idea, but numerically it's a really hard problem to solve until someone came up with how to do it. So the link is in the resources. I encourage you to read that one. It's really fascinating. So what's another problem? Yeah, it's too slow. So you can't do it. Even if you have short text, you just can't make it. It's the investment in infrastructure just doesn't make sense. So what our solution to that was, just extract keywords and compare the keywords. You know, you can compare a couple of keywords for a lot of things using a strong machine. And how you do that? There's a lot of techniques. I will mention some in the end that we used, but that's the solution. And the third problem that I would like to talk about is topic classification. I'll mention it briefly because it has lots of minor use cases in Presley, and it has a need for labeled data. So if you want to do a classification, by definition, means that you are trying to model a label. And you need a high accuracy and low latency, right? It needs to be fast and it needs to be accurate, otherwise you can't use it. So about the high accuracy and low latency, there's a lot of techniques that can do this. For example, these ones, and about 220K more in Google Scholar, and that's since 2016, right? So there is a lot of research going on this. What there is very little research on is where do you get labeled data for a thing like this, and does it make sense to build it from scratch? Which brings me to my point that I would like you to take away from this talk and that is don't reinvent the wheel. Please don't build things from scratch if you absolutely don't have to. It's a waste of time and it's a waste of resources, and you usually end up being worse than if you didn't do it. So how did we do it? That being said, is for related stories, we used a couple of awesome libraries that are open source in Python called Ecstasy and Spacey. Do any of you know the libraries? I'm sure, yes, some nodding. Cool. Yeah, they have implementations of text similarity measures, of deep learning models, of text preprocessing, whatever you need, everything you need, almost. And if you look at, if you ask where do you get the embedding models, they're available. They're open source. There is GitHub repositories where you can get pre-trained word vectors for 90 plus languages. Anything you can imagine, and just use that. You know, it works as good as anything, and probably better than anything that you can build in house. On matching influencers, I mentioned keyword extraction. There's a really cool library called Rake and LTK. Again, it's not great. Keyword extraction is a problem that's not solved by far, but it works, and it will work for you in a lot of use cases. For the text summarization, I mentioned that the paper is really cool. It's actually one of the examples in TensorFlow, if you guys are familiar with TensorFlow. So it's implemented there. You can try it. There is a sample data. You can just install it and run it on your computer. It's pretty cool. And the last thing that we use for keyword extraction is something called Cogito API. It's an actual service that you can pay for, not a lot of money if you compare it to developer resources. And they are probably better than what you can do in a lifetime. You know, if someone is building a company doing what you're trying to do, odds are they're going to be better at it than you if you have 2 weeks to deliver a project. And the last one for text classification, again, there is so many APIs for text classification. They use deep learning, they use taxonomies and ontologies underneath, and so many cool research things that is just not feasible to reproduce that in a time that, especially if you're working in a startup, you will never have. So I highly recommend Alien. If you guys haven't tried it before, it's really cheap. And it does a really good job. It's only available in English, and then I sometimes get a question, then what if my text is not in English? And then I say, well, just Google Translate it, right? I mean, there's an API for that, and at the end, you don't care if the grammar is 100% correct. Google gets it reasonably correct most of the time, and that's it, right? And it's $10 solves your problem. And that's the last thing that I want to mention is please share your work. So for the word movers distance in Spacey, there wasn't a support for Dutch built-in when we started using the software. We had to build it ourselves. It's coming up in the next release. So if you ever want to do word movers distance in Dutch, knock yourself out. But please do the same, right? The community lives from there, from that. And with that, yeah, thanks. And if you have questions, just shoot. I'll try my best.
I think it was a bit of a long talk, so we'll allow 3 questions, and then folks can ask Luca more at the end.
Thank you very much. My question is, I'm not really sure that I got your point on doc to vec, because the way you represent the document can be different. So one example could be actually to say that the whole document is just a bunch of words. Mm-hmm. Another extreme example would be just to say that each line in a document represents a document.
Okay.
And each paragraph can be a document. And why is it a problem? Why can't you just model this on a different semantic level?
Okay, then like on that thought experiment, there's just like going one level higher than making every word a separate document. Right? It's not that much different. The difference there. Yeah,
no,
okay.
No. I can give you example. For example, title, which is the first line in the document, is always very important. And if you represent a document line by line, so semantically different documents having similar titles will be semantically also the same.
Okay. Yeah.
Which you cannot achieve with the Vago Words, and that's the reason why you have a semantic embedding.
Oh, but the word movers distance solves that problem because it looks at the words as a sequence, not as a Vago Words, right?
Well, I'm
so,
not,
yeah. So okay.
that.
So to answer your question, why is it different then? The difference is that there is a lot of really good pre-trained models for word embeddings. For document embeddings, is not so. There exist models in English, but in other languages is a very different story. And again, even the good models that exist for documents are usually trained on documents of sorts like novels or essays, or so they are not really built for sentences or paragraphs. So this is a problem. Like the development resources, compared to that the solution will do roughly the same, because word movers distance takes sequence into account. Will just be higher. So yeah, but you're right on the fact that you can split the document up.
I was just going to ask, go through a lot of websites, and on them I see Outbrain recommending me stuff at the bottom, and it's always really poor.
Okay.
And I was just wondering, are you only recommending things from the same website, like say Emirates, and then Emirates articles, etc.? Or are you recommending in some cases some from external sites and other content which may be more difficult to find good, strong comparisons to? Because I imagine that if it's internal, you could just tag certain topics and it would probably give you better results just to have what's tagged together and do something really simple with that than to use machine learning.
Okay, so there's like 3 questions in there, so I'll try to go one by one. So the first one, we only do internal, so it's newsrooms of our clients, right? So all the content is the content that our clients share. The second, what you say, it would be, what was it? Yeah, it's an easier problem than just to recommend everything. I agree with that. And the third one, wouldn't it be easier to categorize? No, it wouldn't, because it requires that our clients would do it. So, and the point here is to have a value proposition whereas you don't have to do it. We do it automatically. And not only that it saves them time, but if people annotate something manually, it usually sucks. So, it's like it's not doesn't necessarily mean that it would work better. So, yeah, I don't know if that answers your question. I hope so.
Yeah, thanks.
One more question.
There's a hand up there.
Right.
Just on the performance problems of your last one, you were trying to find a recommender, and you need to do that really quickly. Did you actually conceive the document being created but it's not like the document comes into existence immediately. So can you do a partial recommendation based on the first half of the document and then just, because your word mover distance is just going to get closer and closer and closer to some documents or whatever, so you actually have to, can you sort of...
Yeah, I know what you mean. Yes, you can. Of course you can. We usually, for us, the breaking point is when people stop interacting with it intensively. So a lot of the times, because it's kind of I don't know how many of you know WordPress, but the editor kind of works the same, like or Medium, where you can write the text and then you edit the headings and then so on. So we have a threshold on the interactions, and when we can see that the people stop writing and started formatting or debugging, spell checking, then that's the point where we would start, right? So you would get some time ahead. Yeah, okay.
Please join me in thanking LUKAS for a very...
Thank you.
So this is the announcements section. I guess the first and most important announcement is we're always looking for good speakers. Those of you whose companies want to strut their stuff. We're also quite partial to sponsored events by your companies. We've had quite a few of those lately and they're always fun. The IBM one recently has been particularly good. Now is the time to pass the floor to Greg Pearl of EdWorld to tell us a little bit about what opportunities are there in the space for those of you who want to enter data science or otherwise improve your careers. Greg, do you want to use the mic?
No, that's okay. My voice is loud enough. Thank you. And thanks for the presentation. It's fantastic. Before I get started, I'd just like to say thank you for Troy and Beck for videoing this. We're up to probably more than 20 presentations on the Data Science YouTube site, so please go back and look at those. They're all fantastic presentations. From myself, look, I purely focus on data, data science, data engineering. I work across a range of different marketplaces. I do a lot of work in the startup space, across MarTech, FinTech, artificial intelligence, all looking for good data scientists, data engineers, a lot of work with corporates as well. So look, if anyone's got any questions about how to either get into data science or data science opportunities, or if anyone's looking for good data science people, please come and talk to me. I'll definitely give you a good idea about what's around as well. And there's one other thing that I think Eugene's going to be involved with as well, and I'll talk about the next meeting, so I'll know more about it then. But Black Cat Data is an opportunity for people that want to get into data science, scholarship programs into universities and training centres. But I'll tell you more about that next time.
Thank you very much, Greg. And thanks to Greg again for video services. Do we have any other announcements? Yes. Perry.
Hey guys, I'm Perry. I work here at CommBank. Two things. One is please return your visitor passes because Kevin's left me in charge and I don't want to stuff it up. We haven't lost one yet, so don't ruin it for me, please. And the second thing is that the reason we sponsor this is from a talent acquisition point of view. So our talent acquisition team would like to talk to you. Kevin has put his LinkedIn page on the Meetup group, so if you want to talk about careers at CDA, feel free to connect with Kevin on LinkedIn. Thank you.
Anyone else offering jobs out there?
Hi, my name's Molly. I'm here from Vibrato. We are a boutique IT consultancy that mostly specialises in automation and DevOps, but we are also moving into the data space. We have some very interesting projects on the horizon and we would love to talk to you. I'm the community manager. I'll also put my LinkedIn up on the comments for this meetup, but I'll also hang around afterwards if anyone would like to have a chat. Thank you.
That was a surprise. Anybody else? Well, I've got a little bit of good news, but I guess it's as much for the R user group as here. Everyone's a Python user these days, aren't they? But anyone here at all a GG Raptor package user? Hey, 1, 2. Well, the latest version of GG Raptor has just gone on CRAN. So all those people who are working for government agencies, let them download from CRAN but won't let them download from GitHub, you can now use the latest version of GG Raptor, which by the way is an interactive visualization tool, which I'll be presenting more on in the very first visualization stream of Data Science Sydney, which is running on, where's Stephanie? I think it's the 9th. Stephanie? She's in charge of it. I think we're pretty much done. We probably have...
How many more before the end of the year, Eugene?
I don't know, my brain doesn't work. Probably October, November. December may happen if we do it early. That's of these. No idea how many sponsored events, and we'll probably get at least 2 or 3 of the additional streams. So there'll be quite a bit of Data Science Sydney before the end of the year, and certainly a few more of these particular ones.